All right, hello everyone. I'm doing a simple video on elimination method. I'm going to show you three cases: easy, medium, and hard, or harder. None of them are particularly hard. So again, the idea behind elimination method is we're trying to cancel out one variable and then solve for the other one. Now, of course, you can do that with substitution method, but this method uses the principle of adding the two equations in such a way that you can eliminate one variable. So the easy case is the one on the left. You've got a situation where when you add one variable, you'll get 0. For example, I've got 2x and minus 2x. Notice that the 2 is the same, but then they're opposite in sign. So what you have is something that I call equal and opposite in terms of what they are. So 2 and 2 are the same, but one of them is a negative 2. So when you add them together, this goes to 0, which is what we're going to do. We're going to add. And this is going to be minus 3 plus 4y, 3y plus 4y becomes just y. So here you have 0 plus y is equal to 25 plus minus 32 is minus 7. Okay, now 0 plus y is the same thing as y, so y equals minus 7. Okay, that's pretty easy, and now we plug back into one of the equations, so we say 2x, okay, and then it's minus 3 times y, which is minus 7, equals 25. Now, I could have put that back into the other equation, but it doesn't really matter. All right, so I've got now 2x plus 21 equals 25. And if I subtract 21 from each side, I'm going to end up with 2x equals 4, which means that x is going to be equal to 2. So I've got x equals 2. I've got y equals minus 7. So my coordinate pair solution is going to be 2 comma minus 7. And that's it. Okay, so now let's look over at the next equation. Can I eliminate one of these variables by adding? So I can't do that with the x. That would give me 12x. If I can't do that with the y, because that would give me minus 2y. So what do I do? Well, this is the same thing as 1y right here. So if I'm kind of clever, I can decide to just multiply this whole equation by 3 in order to get 3y. Okay, so what I'm going to do is I'm going to go ahead and do that. So 3 times 7x is 21x. And then 3 times y is going to be 3y, which is exactly what I want. Okay, and then 3 times 18, and don't forget to multiply the number over here. That's going to give me 54. All right, so I just adjusted my second equation in order to create a 3y situation. Now I'm going to rewrite my other equation right here. Okay, and then it's 5x minus 3y. Okay, and all of that equals 24. All right. Now I can add down, okay, and the y's will cancel out. So now I'm going to end up with 26x equals, this looks like 78. And if I divide by 26 on each side, you'll see that that's going to be equal, x is going to equal 3. So I figured out what my x is. Okay, and now I can just plug back into one of my original equations. So let's just use the first one. So I've got 5 times x, which is 3, minus 3 times y equals 24. 5 times 3 is 15, minus 3y equals 24. Subtract 15 from each side, and that gives me minus 3y equals 9. And if I divide by minus 3 on each side, I'm going to end up with y equals minus 3. All right, so I've got an xy coordinate pair as my solution of 3 comma minus 3. All right, so the gist of this second one was I was able to multiply one of the equations by a number in order to find the number that would offset the one from the first equation, in this case the y variable. All right, so now I'm going to show you the third and final situation, which is like this. And I call this the harder one because what you see here is I can't add straight down and cancel anything, right? I can't, 3x plus 5x is 8x, 7y minus 2y is 5y. I can't easily multiply just one of the equations by a number to find an offset. So what I'm going to have to do is multiply both equations by some number. Now, for me, it's easier to deal with the y's because I've got opposite signs here, okay? Here I've got a positive 3x, here I've got a 5x. So it's going to be easier for me to multiply this equation by 2 because I want to get 14y, and then multiply this equation by 7 in order to get a minus 14y. So just a little bit of strategy there. So what I'm going to do is I'm going to now do that multiplication and rewrite everything. So 2 times 3x is going to be 6x, okay, and of course that's going to be plus 14y. And I know that because I strategically chose that number to multiply by. Okay, and that's going to equal, now don't forget to multiply the number all the way on the right. So it's going to be 2 times minus 39, which is going to be minus 78. All right, and here I'm going to have 7 times 5x, which is going to give me 35x. And 7 times minus 2, well, that's going to be minus 14y. And that's going to equal 7 times 17, which is 119. All right, well, now I've got the situation where I can cancel out one of the variables. So I'm going to cancel out the y by adding. So this is going to give me 41x, oops, that's 41x, is equal to, and I think that's going to actually be 41. Okay, so divide by 41 on each side, and I end up with x equals 1. All right, that was pretty easy. Now I can plug that x equals 1 into any of the original equations, so I'll just go with 3 times 1. So I'm going to use this first equation. 3 times 1 plus 7y equals minus 39. So 3 plus 7y equals minus 39. Subtract 3 from each side, and I get 7y equals minus 42. Divide by 7 on each side, and I get y equals minus 6. All right, so my coordinate pair solution is going to be 1 comma minus 6. All right, I hope you guys found this helpful. If you have any questions, we of course will cover all of this in our next class. Okay, bye.